So Unit 1 so far has all been about polynomials. If we multiplied them, divided them, learned some new type of factoring, learned how to read them, whether they were to the highest degree of odd, to the highest degree of even, and what that meant. So we are going to do the last thing, which you already did in Algebra 1. We're just going to up the stakes a little bit. We're finding the zeros of polynomials and what that exactly means. So when we were multiplying or dividing, we were looking at their factors. In fact, you're going to do a lot of dividing throughout the course. That breaks it down and makes it easier to look at. So now we're going to take those factors and set them equal to 0. So back in Algebra 1, you were given this problem. X squared plus 5x plus 6. And I would ask you to factor it. And then you would say, oh, this is easy, x plus 3, x plus 2. See, you broke it down into a multiplication property. And then after we did that, we set it equal to 0. So now, when we factored it, we wanted each factor to be a 0. Remember, this would be -3. Because if I put a -3 in there, -3 plus 3 would get me 0. And then -3 plus 2 would be -1. And 0 times -1 gets me 0. Just what I was looking for. But the squared tells you there are 2 possible real zeros. And the next one would be -2. And then we taught you to graph it. And sure enough, there's where that polynomial crosses the x-axis. Those are called the roots. The x-intercepts. And now in Algebra 2, we call them the zeros. So now, where do we put this all together? Well, right now, this is what we want you to do. If given a function, we want you to analyze it as quickly as possible. So, for example, this for number 2 right here. X minus 4 to the third, x minus 2 to the eighth. When you look at that, before we even look at the roots of this polynomial, we want you to know that as the degree of 11, because 3 plus 8 is 11. So that means one root, one tail is down. We have 11 possible times it crosses the x-axis, and then the other tail is up. And that's because the leading coefficient is positive. Now, if it has a degree of 11, that means it could cross the x-axis (11) possible times. That's the maximum it could cross. We're going to find out that it doesn't always have to. For example, this one right here. See how we have x minus 4 to the third? Well, that means that's x minus 4 times x minus 4 times x minus 4. And then this x minus 2 to the eighth, well, that means I've got 8 of those. Let me move this down here. Through the magic of Smartboard, 2, 3, 4, 5, 6, 7, 8. And then we'd set it equal to 0. Well, that's kind of silly, because now we can do all our answers. I didn't really need to write these all out, and of course you're not going to write them all out. I was just trying to show you that that's what this meant. So if you look, even though this is a degree of 11, it only has two zeros or two roots or two x-intercepts. My roots are 4 or 2. And what we have happening here is something called a multiplicity. So we say this has a multiplicity of 3 because it's raised to the third power. So that means the root 4 has a multiplicity of 3. And voila, this has a multiplicity of 8. So it doesn't really cross the x-axis 11 times. It only crosses the x-axis twice. In fact, let's go to Desmos and check it out and see what it looks like. There. I've already typed it in. And if we look, we can see that there's its root of 2, and there's its other root of 4, and that's the only time it crosses the x-axis. We have our one tail down and one tail up. Desmos is going to be a really powerful tool. It's actually a lot better than your graphing calculator. Unfortunately, you can't use Desmos on the regions. But if I'm doing my work all throughout this course, I'd have Desmos up on my computer and my graphing calculator in my hand. So likewise for this third one, find the roots of this polynomial, find the zeros of this polynomial, find the x-intercepts of this polynomial. Well, it's pretty easy. First of all, careful. It has a degree of 101. We have this raised to the 100th power, this raised to the first, so it has a degree of 101. Okay, that means I could have 101 possible roots. But we see that 2x minus 3 raised to the 100th power times x minus 3. Well, we have to set it equal to 0, so that signifies if it's set equal 0 that I'm looking for roots. The x-axis, the x values that will result in the entire equation giving me back the number 0. Well, this one's easy, x minus 3. It has a root of 3. And then this one has a root of 3 halves with a multiplicity of 100. So I have 100 3 halves and 1 3. That gets me a degree of 101. So here's your summary. It's kind of a review. When an equation is set equal to 0, we are finding the roots or the zeros of the function. We can use a calculator to assist us in finding these roots or zeros. We can go to Desmos and then we can press, right? We can go to Desmos and we can press right on it and see what those roots are. Factoring the equation will help, if possible. Ooh, we're going to come with some that don't factor. Remember, we'd have to use the quadratic formula and other lovely tools which are yet to come.